Imagine the Sahara for 1,500 years ago. No trucks, no cranes, no electricity. Yet right here, 23 million stones, each weighing roughly 2.5 tons, the equivalent of 2 adult elephants, were stacked 146 meters high to build the Great Pyramid of Khufu, which still stands today. How did ancient people move these boulders across 800 kilometers of desert and lift them to the height of a 40-story building? Today we uncover the truth step by step with archaeological facts. Let's first get these astonishing facts straight. They only make the mystery more incredible. The Great Pyramid was built for Pharaoh Khufu, taking 20 years to complete. All stones were quarried from Tura, a village 800 kilometers away from Giza, if laid end to end. These stones would stretch from New York to Los Angeles. First key puzzle: how did ancient people precisely cut limestone, a material harder than copper tools? The answer lies in the ruins of Tura Quarry. The ancient Egyptians didn't cut the stones at all. They used a splitting technique. They drilled rows of holes in the rock face, inserted dry wooden wedges, and poured water over them. The immense pressure from the swelling wood split the limestone along a perfect line. This is no guess. Archaeologists have found hundreds of such wedge holes in the quarry, with wooden fragments still remaining in some. Cutting is just the first step. The bigger problem: how to move a 2.5-ton boulder across 800 kilometers of desert. Sand is loose, wheels sink, and even 20 people can't lift it. For centuries, people guessed rolling logs were used, but there are no trees in the desert large enough to support such weight, and no log fragments have ever been found at the pyramid sites. So, what's the real method? In 2014, archaeologists discovered a 4,500-year-old ramp near the Pyramid of Khafre, a limestone-paved road with a shallow trench in the middle and traces of wet sand in the trench. That's the key. Dry sand is hard to walk on, but wet sand is both firm and smooth. Scientists' replica experiments proved wet sand reduces friction by 50%. What took 10 men to pull on dry sand could be done by 5 on wet sand. How to keep the sand wet over 800 kilometers? Archaeologists found remains of canals extending from the Nile River to the construction site. Ancient people transported water via these canals to continuously moisten the runways. To make it even smoother, they laid wooden planks on the paths, and wood fibers embedded in the sand near Giza are still detectable today. Even smarter, they only worked during the dry season, avoiding the muddy floods of the Nile, perfectly utilizing natural laws, solving the transportation problem. An even more mind-bending question arises: how to lift 2.5-ton stones to the top of a 146-meter tower? No cranes, no pulleys. Was there really supernatural power? For years, the most popular theory was a straight ramp built alongside the pyramid. But the problem is, to reach the top, a straight ramp would need to be at least 1.6 kilometers long, and there's simply no space for that on the Giza Plateau. Archaeologists have never found any traces of it. In 2018, thermal imaging of the Great Pyramid revealed a shocking clue: a hidden corridor inside, parallel to the base. This was not a burial chamber at all. It was part of the ramp, combined with the partially preserved remains of the bent pyramid built by Khufu's father. The truth finally emerged. The ancient people used a spiral ramp. As the pyramid grew taller, workers built a 6-meter-wide spiral gentle ramp with a slope of about 10 degrees around the outside, pulling stones uphill using ropes and wooden levers. Holes for wooden posts that held the ropes are still visible in the walls of the bent pyramid. Direct evidence. There's another 1,000-year puzzle: the pyramid's precision. The error between its four sides and the cardinal directions is only 0.05%. More accurate than modern buildings, the stones fit so tightly that a credit card can't slip between them. Without laser ranging, how did ancient people achieve this? The answer lies into simple tools: a plumb line and star observation. They made a plumb line with a stone weight tied to a rope, using gravity to ensure verticality. At night, they observed the rising and setting trajectories of Polaris and its companion stars, taking the midpoint to determine true north, a method still used in basic surveying today. The tight fit of the stones relied on on-site refinement and plaster assistance after rough processing at the quarry. The stones were transported to the construction site for fine trimming with copper chisels. A thin layer of plaster was then applied to the contact surfaces. If the plaster squeezed out evenly during assembly, the fit was perfect. When the plaster dried, it formed a strong bond. As durable as modern adhesives, plaster residue found between the stone gaps by archaeologists is irrefutable evidence of this technique. After centuries of exploration, the truth behind the pyramid's construction is finally revealed. It's neither alien civilization nor supernatural power, but the ancient people's deep understanding of natural laws, simple yet ingenious tools, and unparalleled organizational skills. They used wet sand to reduce friction, wooden wedges to split stones, spiral ramps to lift heavy objects, and stars to determine directional applications of basic physics and natural phenomena, yet achieving such a grand project 1,500 years ago. Now you know the truth. The pyramid is not a miracle, but a monument to human ingenuity. Were you most surprised by the wet sand runway, the spiral ramp design, or the precision achieved with only basic tools? Share your thoughts in the comments below. Follow me, and next time we'll uncover the structural secret that has kept the pyramid standing for 4,500 years.